And another important thing to remember is that alcohol does not necessarily, as a matter of fact, many times, it does not just mean ethanol, which is what this right here would be. Okay, and that is, by the way, how they are named. They are named for the group that you have here with an OL on the ethylene. So this would be ethane. Ethane becomes ethanol. Okay, and you can have, if it were just a CH3OH, it would be methanol. If you have 3 of them, it would be propanol. If you have 4 of them, it would be butanol, right? So there's a whole large variety of other alcohols that can be formed in this manner. Now, it's also possible to have more than one of these OH groups. Anything with an OH group bonded to a carbon, directly to a carbon, is an alcohol type of group. But this right here, you've got 2 of them. This is 1,2-ethane diol, also known as glycol. And this is 1,2,3-propane triol, right? So you count off where the different radical group, the functional group is, okay? The OH in this case. And you put the number of it in front of the ol, because there's 2 of them here, so it's a diol. And so the number, where the location is, goes here, the number goes here. So here's 1,2,3-propane triol. Okay, now this one right here. It's located, remember, you're trying to get the smallest number here. 1, 2, 3, 4, 5. So that's going to be pentane, right? So this is going to be, this is on the second one. So this is 2-pentanol, right? Just like we had right here. Okay, so 2-pentanol for this one. 2-pentanol. Here you have another group on the second one as well. You have 1, 2, 3, 4, 5. So it's again a base of pentane. So this is going to be 2-methyl 2-pentanol, right? 2-methyl and then another 2, because you also have the OH off of the pentanol. Now, instead of having the oxygen bonded to a hydrogen, it could also be bonded to another H, or to another carbon, okay, instead of an H. And so in this sort of an instance, it's called an ether. And you use the 2 different names. You look at what's on one side of that oxygen, and you look at what's on the other side of that oxygen. And so this would be methyl ethyl ether for this particular one. This right here has got an ethyl group here and an ethyl group here, so this would be diethyl ether. And here what you have is in this type of configuration, this would be isopropyl, right? Isopropyl. And so this would be this would be isopropyl methyl ether. Isopropyl methyl ether. And how these are formed is you take 2 alcohols together, and then if you heat them up in the presence of an acid, what happens is you lose a water molecule here. So this is ethanol and ethanol to form diethyl ether plus water. Okay, so this is the reaction with acid and heat to form an ether. And what you would do is you would use different alcohols if you wanted to come up with a different type of ether. This right here illustrates something we should be all fairly familiar with. All these OH groups are on sugars. Okay, and this is 5-member ring for fructose, and here you have 6-membered rings. This is a glucose and this is a glucose. If they're bonded together in this manner, it becomes lactose. If you have a glucose bonded with a fructose to form a disaccharide, that becomes sucrose. And diabetes is characterized by high concentrations of glucose, and one of the key things is monitoring that blood level. And so these monitors have been developed over the course of years to monitor that level, and so that people know when they have to take an insulin injection or some other form to ensure that their insulin levels maintain constant, fairly constant. Okay, now we're talking about aldehydes, ketones, carboxylic acids, and esters. These are all grouped together because of one common group. Each of them has something called a carbonyl group, a C double bond O, and with bonded to 2 other things, right? And that could be a hydrogen, it could be an oxygen, it could be carbon, all sorts of different things that could be bonded here. But if it's a double bond O here, this is a carbonyl group. And if you just have an H on one side and R means some other carbon group out this way, this becomes an aldehyde. Okay? If you have carbon groups on both sides of this one, this becomes a ketone. Okay? So this is just another figure of a ketone. This is ethanaldehyde, right? This is acetaldehyde. This is your acetic acid is what this would be, so this is a common name for these. But these end in hyde, right? So you can have either ethanal or acetaldehyde. If it's ETHANAL instead of an OL, you know that it's a double bond OH here instead of just an OH bonded together, right? So, or it's just called an aldehyde. This right here is butanone, okay? And then ONE. And so this right here is butanone, and the way in which they talk about it is 1, 2, 3 here to where this is, and then only 1 on the other side for it to have that particular name. The low molecular weight ones are ones that are, you almost have to memorize all their names because there's a lot of history behind the different ones, just like acetaldehyde instead of ethanaldehyde, or butanone instead of the other names for these. Now the carbonyl group is polar, so the geometry of the bonds around is trigonal bipolar as well. And that also relates to the sort of interactions that it can have. Now, how are they formed? First of all, you start with an alcohol. And you oxidize that alcohol to get the carbonyl group. And depending upon whether one of these, if both of these are carbons, then what you're going to end up with is a ketone. If one of these is a carbon and one of these is a hydrogen, then you're going to end up with an aldehyde. So alcohols, depending upon what particular type of alcohol it is, can either form an aldehyde or a ketone, but it's through an oxidation process. Sometimes in reactions, this is just written with a bracket, an O, and another bracket on the other side of the O. So if you started off with this one right here, where you have OH right there, and these are H's there, what you would end up with is a double bond O there, wouldn't you? Right? So starting from this one, you'd end up with this. Now, if you oxidize it further, what happens is you get a carboxylic acid. So if you go from this right here, where you have an aldehyde, you oxidize the aldehyde further, and you get an acid, a carboxylic acid. These are the weak organic acids that we talked about and that we actually did the titration with. Acetic acid, which is what this right here is just one example. Okay? And so you would start off with this material. Well, actually you start off with the alcohol. And then you can either react it to reduce it so that you get just other hydrogens there, or you can react with, you can oxidize it to form this, and oxidize it further to form this. So this is an alcohol becoming an aldehyde. This is an alcohol where you'll notice that this carbon right here now has carbons on both sides of it, and so that's going to become a ketone. And this right here is your very famous acetone. Now, another thing, this is a little bit out of order because this should have been after we talked about the acids. If you have this type of a structure, these are called esters. And so in your oops, I guess I didn't see it there. Okay, if you take this material right here and react it with something on an R group, so we add the R group to here, you then form an ester. So it has a carbons out this way, a carbon double bond, an oxygen, and then carbons out this way. So you take an acid and then react it with some other organic group, and you then form that ester out here. The reason why that's important is because those are very, very important for smells and the things that have the things that you typically associate with very fragrant things like peaches or oranges or wintergreen or honey. These particular esters give them their distinctive scents. These are low molecular weight materials that, well, some of them aren't too low molecular weight, but what they are is they have very low volatility. So that very high volatility. High volatility means that they are easy to get into the air and you can smell them easily. So these are the pleasant smells that you have. And this right here is acetic acid. And when you replace this right here, this is methyl acetate, right? So you take acids, react this hydrogen right here, put a radical methyl group or some other carbon group over here, and it becomes then the methyl is from this part, and then the long chain is what becomes the O8, right? Ethanoate. Okay, so this is methyl acetate is the name of an ester. Propionic acid, you can react that with sodium. Okay, so it is a weak base in solution. You can titrate that. And what will happen is you'll get the propionate ion along with sodium ion plus water, right? That's a typical reaction for a neutralization. Also, the aldehyde can be oxidized to form an alcohol. Alcohol can be reacted to form a carboxylic acid. So these are each stages of oxidation of these. And then once you have the acid, you react it with an alcohol again, and that's what forms this ethyl acetate, right? So it's whatever this alcohol is, that's what replaces this. So you have the H2O coming off of here again and forming that type of material. This is just one of many different ones. I'm going to stop here and then we'll talk about amines and amides.